Okay, guys, lesson number 8. We have actually attempted or answered, not attempted, answered all the questions that were sent. No new question was sent so far. But then I have some questions that we jumped. Can we look at, so that we have a full 360 degrees of physics? We've looked at vertical, momentum, work, all of those. Please go use, you still have a full day. I think we have about 5 lessons or 4 that we spent only on paper 1. You just need to check them on the playlist. All right, let's see. It's a mixture of paper 1 and 2, but I know I do have. There we go. All right, there we go. Would you want to answer this 14 marks for me? I'll give you 10 minutes. Yes, I don't have peace. That's what your face saying, that I Mara, this guy. I have no chill. No chill in Mzanzi. 10 minutes. We can get, because the major work is on 9.2 where we have 5 marks, 5 marks. The rest are 1 mark, 1 mark, 1 mark. After this, I want multiple choice. guys, let's mark quickly, very fast. It says AC. I'm going to say some important points as we go on. AC generators and DC generators differ in their construction and the type of current they deliver. What type of generator is this? AC or DC? What's your answer? Sitley. AC or DC? Angela, since Sitley has decided to divorce me and not talk to me. You said what? AC. Why? Split is DC. Look at the letter D and C. That's how you're going to remember. It's a circle that has been split into two. Okay. Can you see that, right? D is half a circle. C is the other half of the circle. So that's how you remember. So with a DC, and what is the reason? It contains a commutator. Please, if you write split ring alone, you'll get a 0. The mark is on the commutator. Okay? And if it's AC, what will it be? Slip what? Rings. So our answer here is what? DC. Half. And those are my commutators. State the energy conversion that takes place in this generator. Which generators? I did a few notes in the last lesson on generators. I did a quick summary note on generators. Okay, what's the energy conversion? Mechanical to electrical energy. I hope you are all marking. Number 3, which component, X or Y? Yes, I've got a hand there. Yes, MEM. MEM, motors convert electrical to mechanical. Which component, X or Y, enables the generator to produce the type of current it delivers? It is Y. What is X? X is a carbon brush. Let's quickly, we spoke about this. I can show you the notes. Carbon brush. And what is the function of a carbon brush? It is just, it's a conduit, all right? It passes current from coil to external circuit. And vice versa. I'm going to tell you something about that carbon brush just when we finish this. Will the coil experience a maximum or minimum tug? Tug is a turning effect if the coil is in the position. All right, good question. Is this at this position is going to experience a minimum? Yebunana, minimum. I'll explain. Minimum. Guys, why am I saying minimum? What pushes this thing would be the force here. But you can see that the magnetic field is not actually connected to the coil. It's parallel to the coil. Imagine if the coil is standing. It's like you're pushing something. That's when the experience is maximum. Tug, the maximum force. Make sense? All right, so it must be in that direction. 9.2. I hope it makes sense, everybody. Electrical device is connected to a generator which produces an RMS. All right, so we know VRMS as 210. Make sure you have a list. Maximum current, Imax, 6 amps. Calculate the resistance. What do you do? Make it all RMS. Better all the time. Yeah, although you get the same answer, but make it all RMS. So I RMS is equal to what? Imax over what? Root 2. So if it's work with all RMSs, it's always preferably. What is Imax? 6 over root 2. Now can we use Ohm's law? V RMS equals to I RMS multiplied by R. 210 equals to 6 over root 2. Give me your value of R. 210.
35.
That's the same answer you got. That's the same answer you got? Change it into decimal. 49, 50. But preferably work with RMS. What did you get? What did you do, this child? So long. Why so long? From current, you calculated power you calculate. Nana. Energy. How do we calculate energy? Guys, please understand, energy is the same as work. Energy is the same as work. Because you might be looking for what's the symbol of energy.
Yes, that's what I was looking for.
Good. So now you know that energy, that's why we say work energy. You see. So when the examiner says energy, they're actually referring to what? Work. What do we have? Energy of the device. We have T equals to what? 2 times 3,000 what? 600, right? Which is 7,200 seconds. What's our formula? If you check your formula page, you'll see W. I think there's a formula that says V. Alright, but check. I'm not just going to write that, right? VI what? Delta T. Huh? Is that fine? Yep. RMS. What is my VRMS? 210. What is my RMS? And what is the time? No, you're going to get the same answer. Check that one. Showing me so many calculators. Showing off. But that calculator is bandaged. Okay, give me an answer to this. 64. 2.
872.
Uh-huh.
0.719.
Let's try another method. Oh, joules, sorry.
V squared delta T.
W equals to what? V RMS squared delta T over what? R. Is that fine? So what's my VRMS? 210 squared. 7 that. What is my resistance? We got a resistance, right? What was it? 49.5. All right, our answer will be slightly different because of the decimal. Shoot. What's your answer? Six four. Yep. 4 5. All right. The reason why we
don't use RMS, you don't get the same answer.
you must use RMS in this question. You need to specify the V that you're using. You don't just write V in this question. All right, guys. I hope we're okay. Did this question make sense? Come Friday, get all the marks. Yes, there's a hand. McDear?
Can you please just explain 9.1.4 again?
9 point?
1.4.
All right, so we're talking about a force. Is that okay? And the force that you're talking about will be a force read from, or that is caused by the force field here, north to south. Is that okay? You see, when that hits the coil, it actually rotates. All right? So,
Okay.
so when the coil, okay, it's a generator. Naturally, this coil would rotate. But when it's now standing, what do you notice? There's a push.
Oh, okay.
As you see, as it is horizontal like this parallel force is actually not touching the coil. I don't know if that makes sense.
It does.
Yes. All right. Okay, guys, we okay with this question? Just want to quickly show you something here. Very, very important. In our last section, I remember talking to you about energy and whatnot. But I just want to mention something very important here, and then I'll give you a chance to look at the next question. Then we can I'll look for Doppler. I think we've done those difficult ones. We just now want to relax and hit those other questions that we neglected. Normally we say it's simple, and then, all right, guys, if I have a coil here in the middle, and then I have, what is that? Split ring, right? You can see it halfway. And I have that. Okay. Is this a generator or a motor? Please give me reasons. Whatever answer you choose.
The rheostat is connected.
The rheostat is connected to your said it's a motor. Okay. Sit there. So a resistor means it is a I didn't just think. Guys, I need answers from home. Is that a generator or a motor, and what type? DC what? DC what? DC motor. Gracia says a generator. Tumeleng says a generator. Google says a generator. A DC generator. Alright. Mjeni actually gives you the whole reason. DC generator because there's no power source.
So a motor needs a power source.
Huh? A motor. Well, what are we converting? Your fan. That's a motor there. Your fan working. It's a motor. So if there's no power source, it is a generator. That's a light bulb. It's a light bulb, Nana.
The rheostat is on. Okay.
That's a light bulb, which also works as a resistance. So I want to light up this light bulb. Okay. All right.
Quick question, Soldier.
Yes.
I know rheostat is like change the resistance.
Yeah.
What's
A rheostat is called a variable resistor. A resistor that allows, it's like a knob. You see your good question, good answer. Look at the fan. That knob that you change, that's a rheostat. Because you are varying the resistor. So if I change that, what happens? I either reduce resistance or increase. If the fan starts moving faster, what am I doing? Decreasing resistance, increasing current. So that's a rheostat. All right, here's the question I want to ask you. What type of current are we producing? Okay, you guys said DC. I'm going to call this point X and point Y. Please write down the type of current that is in X and the type of current that is in Y. Simple question. Write down the type of current that is in X and the current that is in Y. Current in X and Y. All right, Mjeni, which question is this?
I don't even understand what your question is.
I'm saying what type of current do we have in X in the coil, and what type of current do we have in Y in the external circuit? It's a generator. We are producing current.
External resistant current.
External what?
External current.
Child. Don't make me. Okay, Mieni, I got you, but can we do that on Friday or our next chemistry class? Would that be possible, Mieni? Just so that today we just focus on paper one, but I'll add it to the stuff.
No problem, sir.
Okay.
Can I also send you my question?
No, don't send me your question, please.
Marawai.
No, you cannot send me an Arsenal fan. I don't take questions from Arsenal. Sitley, do you have a soccer team?
Yes.
Which is your soccer team? What is it? Okay, no, I'm not disappointed. It's fine. United, you're still okay.
Why? Because they're not Liverpool. They're not winning.
No, United, you're still okay. I'm
Liverpool.
still game for United.
Do you understand the shame?
Guys, talk to me here. Let's leave Chelsea and spot alone. X and Y, quickly. X is AC. Please, let's take note. The current generated here is AC, and the current generated here is DC. Why AC? Electromagnetic induction always produces alternating current. Electromagnetic induction always produces what? Alternating current. Always. And you know the graph there, right? Always. But here DC, why? The commutator converts the AC to DC. We spoke about the function, so we're going to have it there. So every time you have a coil moving through a magnet, we will always produce AC. Take note of that. Every time you have a coil moving through a magnet, although it's a DC generator, but first in the coil, what's happening? We are producing what? AC. Take note of that point. That's a very, very good point. We okay? Next one I want to mention, then we answer one more question, then move forward from. I want us to do multiple choice. I feel like some multiple choice today.
First, can you do my question?
What's your question?
Let me read the joke. Is that no.
Okay,
My question is electricity.
All right. No problem.
Electric circuits.
It's fine.
Everything else I have accepted. Electric part of IT. How do you explain that?
Okay, look at this one quickly. The angle of the coil. Now, here you have 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. When we produce maximum, your coil is actually slipping like that, even at minimum. But when we produce a 0, your coil is vertical. I'm going to give you important note here. On the x-axis, what angle am I measuring? I am measuring angle between coil and field. Angle between the coil and the normal, not field. So if I were to draw my normal, check this. This is what I wanted to see. If I were to draw my normal, perpendicular like that, right? You would notice this angle here, 90 degrees. The coil is slipping and I'm drawing a vertical line on top of it. 90 degrees. That's why we have that. However, so I'm going to quickly pinpoint two important points here. Here, The coil is standing vertically. Between the magnets. Angle between coil and normal is equal to 0. Angle between coil and field is equal to 90 degrees. Please, I want you to take note. I want to show a multiple choice where they ask such questions and you are likely to get it wrong if you are not paying attention. Here, coil is horizontal. Now it means the coil is parallel to the field, which is 0 degrees, and perpendicular to the normal. I want you to notice how those two angles are changing based on what is measured. Yes, talk to me, Emmanuel. Hi, Emmanuel, how are you?
I'm fine.
I'm good.
Do you see by, like, okay, you put that the coil is standing vertically, when the coil is standing vertically between the magnet?
Yes.
You said that the angle between the coil and the normal is equal to 0.
Yep.
So what do you mean by normal?
All right. Guys, I know you're writing, just pause a bit. I knew that this 0 and 90 would be a bit of an issue, so I hope I'll be able to explain with this diagram. Let's just quickly go to this. Look at the same question. What do you notice in the question here? The coil is slipping horizontally, right? At this point, I am actually generating maximum current. Is that okay? A quick idea is, if you were to stand facing someone and I put a barrier, a paper in between both of you, if the paper is standing vertically, we cannot see each other. I want you to use that. That's 0 current produced. But when I make the paper in between us horizontal, I can see you, you can see me, there's no barrier. Current is maximum there. All right, so I want you to watch this. With the way this is, what we are saying is, let me see if I can cut out this picture and use it for a better explanation. 1 second, just trying to, because I know that this part is always a bit of a ice to glide over. I'm just going to make this image very big and make my notes. You just need to take a picture of this when I'm done. All right, it's going to be a lot easier for you. Come, clean up. All right, so this is what I wanted. At this position, what do we notice? The coil is what? Horizontal. But where is my normal? That's the question Emmanuel is asking. Your normal is standing vertically like that. So what is this angle? Does that make sense? Can you imagine that? So your coil is horizontal like a flat surface. Normal is vertical. That's 90 degrees. So at this point, what are we producing? We are producing what? Maximum current. When do we produce maximum current? Watch this. Look at my answer. The field is parallel to the surface of the coil. I'm going to go to draw that now. The field is always moving from the North Pole to the what? To the South Pole. I don't know if you see that parallel. Right above the coil. Parallel. Make sense? But, so if it is parallel, the field, why is my board behaving? Parallel to the what? Oh my board, I don't even remember what I wrote. When I say parallel, what is that? 0 degrees. But what's happening? The coil is perpendicular to the normal. And what is that angle? That's why if you go to my graph there, if you go to the graph, you would see the 90 degrees. Okay, you see the 90. Coil is vertical. I don't know if it makes sense now, guys. I don't know if it makes sense. Okay, you're writing this. Let's see. Are we good? Did it make sense? Let me see thumbs up, thumbs down. This here, it's the language that the examiner wants to catch you on. The 0, the 90. So you read carefully, especially multiple choice. Read carefully. Just imagine you are looking at someone, there's someone in front of you, that's the field. You're looking north to south. For us to have maximum visibility, the paper in between us must be horizontal. That is parallel to the field, but perpendicular to the normal. And if I put that paper up, what happens? It is now perpendicular to the field, because the field is hitting it, right? 0 degrees or 90 degrees there, but parallel to the normal. So it just, the angle changes. That's the thing. The 0 and the 90 just changes. Make sense, everybody? Let's answer one more and then find something. Okay, wait, which year is your question? Do you know the year?
2021.
Yes, before we move on, Charles. All right, I'm going back to the, which graph? This is a graph. Which diagram? This one? This one? Okay, just trying to answer a question here. Oh. Okay, direction of flow of current. I cannot answer that in this case because I need two things. I need to know whether the coil is moving clockwise or anti-clockwise. That's your question, right? Okay, so I also know the direction. Let me see something here. All right, we'll be able to answer it from here. Guys, 1, 2, 3, 4, 5 marks. You have 3 minutes. Let's make it 4. Because you have to read. Please make sure you start reading from the top. Some of you just look at the first question. Like I know, Angela, you are guilty as charged. I'm right. Okay, let's get this 5 marks. Identify the two devices, which one, between the two devices, which one is a generator? X or Y? AC generator. X or Y? It's X. You would see at the bottom, you notice there's a power supply at the bottom there. All right, so this one is a motor. And what type of motor? DC. And what is this? AC generator. Okay. State the energy conversion that occurs at Y. We know that, right? Electrical to mechanical. Name one principle. Name the principle on which generator operates. We did that. Electromagnetic what? Induction. Electromagnetic induction. That we did in details. Number 4. Name one structural difference between the two devices. Structural means how it looks. What's the difference between the two of them? Slip ring and split ring. Split ring, commutator. In what? In Y. Slip ring in X. Number 5. Write down one way to improve the efficiency of device X. What are we doing with X? We are producing what? Current. How do we increase its efficiency? Use stronger magnets. They're just saying, how do we produce more current? Increase the number of turns. Of wire on the coil. Number 3. Increase the speed of what? Rotation. Yes. Huh? They said 1. I'm just giving you everything. Yes, Itumele.
Evening, sir.
Hi, Nana. How are you?
Good evening, sir.
I'm okay. Talk to me.
So I wanted to ask for 9.1.4, could we say that Y has a power source and X doesn't?
Yeah, that's also correct. That's a structural difference. You're right there. Y has a power source, X does not have. It's a structure. Don't use larger magnet. A magnet can be big, but not strong. I'll give a very good example. Your earphones use magnets, and they are better than some big speakers. But they're using a smaller magnet, so it's not about the size, it's about the strength. So don't say use larger magnet. Use stronger magnets. Are we okay? This is just theory here. Examiner is checking if we know all our theory. Okay. All right, we have 8 marks. Quickly calculate for me. I'll give you 5 minutes. This is electrodynamics. Calculations usually don't take long. Guys, if you are done, please share answers. Don't be shy. I need as many answers as possible. Number 1 and number 2. Please share your answers. I'd love to see. Please, please, please. Everyone start sharing answers. Starting from here.
You always answer first.
Okay, the guys here say no, they are refusing. That they always answer first. That you guys at home, you just copy. Is that not what you said? Yeah. So, oh, Sitley is now defending herself, you see?
They said the answer. Good people.
Okay, Alan is trying to say no, they are wrong. So Alan is throwing in answer 28,28 and then 27,58. Okay, Sitley says, Alan, thank you for sharing your answers, but your answers are wrong. Sitley.
Okay, 9.2.2
Alan can hear you, so talk.
So,
Wapona in.
is for 9.2.2.
Yeah.
What I wrote doesn't look like it's for 5 marks.
What you wrote doesn't look like it's for 5 marks. Okay. What's your own answer, Asana?
I got the same answer as everyone else shared.
Who's everyone else?
It's here and then.
What's your first answer?
28.228.
Okay.
We.
And number 2?
We. Same 27.58.
Okay. Tumeleng, what's your answer? Don't worry about whether your answer is right or wrong. Share. Divine, Hando, Tondani, Kamps, Bate, Mieni, Emmanuel, Angelina, Gugu, come on, Gracia. There are so many people. So many intelligent people here. But they want to hoard their answers. Nji. Just you. Eh? You answer? Yeah, I know you are now you are changed. Determine the peak voltage. I think that one is straightforward. Let's see, Matia. Are you okay there? What's your answer? Peak voltage, what do we know? VRMS, right? What's the formula? VRMS equals to what? Vmax over what? And by the way, do we know where to read VRMS from if they give you a graph? Do you know where to read it from? No, that's not what I mean. All right, so if they give me this, this top part here would give me my Vmax, and VRMS is just below. That's why your VRMS will be lower than your Vmax, because maximum talks about the highest, the peak, but it will produce the same power. Okay, what is my VRMS? So Vmax, can we say Vmax is what? 20 root 2. What's your answer? All right, so you 1, 2, and 3. Calculate the average power delivered to the speaker. What do you know about the speaker? The speaker has a resistance of what? 14,5. How do you calculate power? It's either we say P average equals to I RMS multiplied by what? V RMS, or I RMS squared R, or V RMS squared. So do we know resistance? Yes. But you see it's 5 marks. The question is, what is the voltage here? There are so many ways. I'm going to go through the simplest one for you quickly. I say about 3 ways of doing this. I could calculate the voltage using ratios. Okay. But we need to calculate, if we can get the current, that's why it's 5 marks. Since these things are connected in series, the current would be what? the same. So let's calculate the total current here. I total. What do we know? V equals to what? IR. 20. What is my resistance? 8,2 plus 14,5. Do you want to give me an answer? What's my current? 20 divided by all of that. Sorry? Zero comma? Now I can calculate the power in the speaker since I know my I. I, please, again, R. What do you have? 0,88 squared. What's my resistance? 14,5. This is just one of the ways by using the formulas that I have. What's your answer? Did you square it? Did you put square?
Yeah.
What answer? Huh? Comma 2 what? Child, what's wrong with you? I don't know if it makes sense, guys. I don't know how you guys got your answer, but that's why it's 5 marks.
And that's the only method.
No, this is not the only method. But your method, whatever you get should be close to this. Yes, Itumeleng, talk to me. To me, your hand is up. Yep.
So I used the 11 method. That's how I got my 0.88. That's what I'm not understanding. Okay.
You use what?
So I use P average is equals. I use P average is equals to V RMS squared over R to get directly to P average, but it gave me 0.88 as an answer.
Okay, come with me. You said you what? P equals to V
RMS squared over R.
It gave you what?
It gave me 0.88.
All right. Let's use knowledge of electricity again. How are these things connected? So can you see that the voltage will be divided? So you cannot use that. Yes, I'll do another method, but let me listen to all your questions. Using V as 28,88. The thing is, we cannot use 28,88 because we are looking for power. The formula for power says RMS. You need to be mathematically, you need to see some mathematics there. But however, the voltage in the 8,2 is not the same as the voltage in the 14,5. Okay, the voltage, so power is associated with RMS. Although, if we use V max, we must be using I max, according to mathematical manipulations. Let's try another method. Can we find the voltage in the 14,5? Let's try. Let's try the voltage. No, it's not. These are connected in series. Series are potential what? Dividers. So what I know is that current is what? The same. Check this. Can I call this A and call this B? So if I have A and B, what is the resistance here? In A, 8,2. What is the resistance here? 14,5 ohms, right? And we want to divide 20 volts in this ratio. How do we do that? Let's try something quickly. What is 8 comma 2 plus 14 comma 5? All right, so I can then say 8 comma 2 over 22 comma 7 multiplied by 20. Give me an answer here. I want us to see something. And then 14 comma 5. Quickly, I need answers. Time. Yeah? What about this one? 12 comma? I want to see if that would make sense though. If you add both of them together, are you going to get 20 volts? Yeah. Yeah. So this is another way. Answers will just be a bit different. Okay, so let's try something here. So this is the voltage in the 14,5. What is my power average? V squared RMS over R. Quickly, start typing. And what is the resistance? 14,5. Let's see what answer this would be. What was our answer earlier on? Alright, so it's the knowledge of circuits that we need to bring in. If those things are connected in series, what happens? Potential difference is divided, but current remains what? The same. So I used ratios here by dividing. Okay, 8.2 out of the total 22,7 times 20. Let me know if this makes sense, people. This is using the same knowledge of circuits. Okay, we're good. I don't want to hold on. No. Okay, I have one more on photoelectric effect. Then I can take your questions quickly. But guys, please just tonight try to do. Oh yeah, there was a time we did the multiple choice. Do you remember? I think it was before prelims. Yeah. Let's see. I want us to take one multiple choice tonight. 10 questions. And just enjoy. And that will allow us go through the full concept, talk about so many things. But before that, we have one photoelectric effects to answer. And they have your question. What's your question again? 2020? Is it difficult? Okay, let's answer this quickly. Quickly. Why are you dancing? Okay guys, let's go through this together. 12 marks. Can I give you 10 minutes to try? Please. Photoelectric effect. Most of these are definitions. Oh yeah. I just don't like doing questions for learners. I don't know. It's just not me. No matter how pressured we are. question.
We can cry.
All right, guys. The table below shows different metals. Let's see quickly so that we touch on this as well. Light, now we have threshold. Quickly, please. When will photoelectric effect occur? Conditions again. Make sure you know your definitions. Conditions for photoelectric effect. We said W should be, E, the energy of the light. The energy of the light must be greater than work function. Frequency of the light must be greater than threshold frequency. The wavelength of the light must be less than the maximum wavelength. And all of this will point to the fact that kinetic energy is greater than 0. If my kinetic energy is less than 0, then there's no photoelectric effect. Define threshold frequency, minimum frequency of light needed to eject an electron from the surface of a metal. We're done. All right. In which metals A, B, C, D will photoelectric effect not take place? Please, all I'm doing, guys, I want to quickly warn you, be careful of the exponents. So first thing I did was to check all the exponents, they are the same. If they are not the same, use a calculator. All right? If they are not the same, use a calculator to check the values. Okay, no problem. Absorption and emission. I'll explain that. All right. So if you look at the light, the frequency of the light is greater than A, greater than B, greater than C, except for what? D. So what's my answer? What's your reason? The frequency of the light is less than what? The threshold what frequency? You're done. You don't even need to write stories. The frequency of the light is less than. The frequency talks about money you have. Threshold frequency talks about the price they sell the commodity. It's like asking me if I can buy a Rolls Royce. Really? I mean, I belong to ABC, you know. Buy a Rolls Royce, can do that like Tata, order from Take a Lot. Emmanuel, why are you laughing? Order from Take a Lot if they have. The only reason I will not buy from Take a Lot is if they don't have. So Google, please start Googling. Maybe on my Android it's not going to work. Google on your iPhone. Can I get a Rolls Royce from Take a Lot? If they have, please, I'm ordering. I should get you a MacBook. That one you can even order from Spaza Shop.
Don't forget this.
That's how rich I am. I can order from Spaza Shop here. Okay. All right. But I hope it makes sense, guys. The frequency is less than the threshold. You guys like laughing a lot. Frequency is less than threshold frequency. So there is no photoelectric what? Effect. Calculate the highest. I love this word. Highest. Where will I have the highest? I'll have the highest where I have the smallest wave function. All right. 10.1.3. EK is highest where work function is lowest. EK is highest, I hope that makes sense, where work function is lowest. Look at what I'm going to say. For the same E. I think I did answer one question on the group like that. Let's see where we're talking about we shouldn't use directly proportional stuff. So which one has the lowest? C. Done. So E equals to work function. I'm looking for kinetic energy, right? But what do I have? Frequency. HC over frequency. No. What am I saying? I have frequency, right? So it's HF minus HF naught plus EK. I'm sure, guys, we can do the math here. What are we using? We are using what? We are using C. Yes, can I? Oh, Emmanuel, I should order for you too. Ah, sweet. Send me your address. Okay, what is H? 6,63 times 10 to the power what? Negative 34. What's your frequency? Are we fine there? What is H again? 6,63 times 10 to the power negative 34. What is the threshold frequency? 0,06 times 10 to the power what? 14 plus kinetic energy. I hope, guys, can you finish that and you're done? Oh, but we're not done. They said maximum speed. That is kinetic energy. Okay, let's do it. What is my EK? I need maximum speed. Otherwise, it shouldn't be 5 marks. Can we do the maths, please? All right, I'll do it. Where's my calculator? Okay, all right, I'll help you now. 3,15 times 10 to the power 14 minus 0,06 times 10 to the power what? 14. Check your answer. Is that what you have? Is that what you have? You sure? All right. 2, don't round off yet. 2,048. You have that answer? Because I need it. Are you okay? Is that what you got? All right. Why am I not done with this question? The examiner wants maximum what? Speed. What is my formula? Sita, do you have that? You guys have this answer, right? Keep it for me. But EK is equal to what? Half mv squared. Give me that answer again, very fast. Time. Kinetic energy. 2,0. Come on. Okay, here's my answer. 2,04867. 04867. 2,04867 times 10 to the power what? 14. Now what do? You look for the mass of it's negative 19. I knew something was wrong. Negative 19. What is the mass of an electron? It's there on the formula page. 9,11 times 10 to the power negative 31. And you have what? V squared. Now you can do the maths. Now we can do the maths. All right, I'm going to say answer multiplied by 2 and divided by what? 9,11 times 10 to the power negative what? 31. And I have to look for the square root of that answer.
67043.64.
All right, give me that answer again. 6.
670. 643.
Comma.
64.
Meters per second. So please remember, the lower the threshold frequency, the lower the work function, and the higher the kinetic what? Energy. But don't use the word proportional. Don't use the word proportional. Guys, are we okay? So we can have time to explain emission. All right, 10.1.4. If the intensity of the light radiated is decreased, what does intensity mean? Number of photons. Don't forget that. All right. What will happen to the speed? Look, number will not affect speed. So it will remain what? The same. Number will Number will just remember something now. Number will affect what? Number of electrons. Energy will affect what? Energy of electrons. What? No, Revive works on electricity. Here, you don't understand 10.1.4. Okay, let's quickly look at this. This is what we're saying. Quickly trace it. What is intensity? You must understand what that means. Number of what? Photons. And I'll quickly give you the notes. increase in intensity. What would that mean? That means the number of photons increase. And you know what this would mean? It means number of electrons ejected will also increase. And you know what that means? Current will increase. And you know what that is saying? The kinetic energy of electrons remain what? The same. And they will put this for you in a graph. What did I write here? What's wrong with my board? Current will increase. Kinetic energy remains the same. And like I said, they will throw these to you in a graph for you to interpret. So I'll draw the two graphs that explains this. Intensity, kinetic energy, intensity, and current. This one will not change, but this one will increase. Okay, what's wrong with my board? Why is it skipping?
The word is vanished.
Number of what did I write?
Number of
Photons will increase. Number of electrons ejected. Let's add something to that. Number of electrons ejected per unit time, because we're talking about current. Yeah, that's very important because current is measured with time, right? Current will increase, and that's your graph there. Kinetic energy will remain constant as intensity increases. I'm going to steal 30 minutes. Is it fine? All right. What about energy? Of if I increase the energy of photons, what will happen? How can I change the energy of a photon? Change the light. Remember, E equals to what? HF. So E is directly proportional to F. A light of higher frequency would have more what? Energy. So how would that happen? So using a light of higher frequency, energy of photon will increase. But the number of photons remain what? The same. So what would this impact on? Since the number of photons remain the same, you know what it means? The number of electrons will also remain what? The same. Number of ejected electrons remains the same. But kinetic energy does what? Increases. Current remains the same. And I'll draw the graph of this one as well. Current remains the same. So if I change frequency, what happens? Energy of the light will change. Energy of the electrons will change. But the number will not what? Change. Energy will affect energy. Number of photons will affect number of electrons. So number, energy, energy. Number, energy, energy. Let's draw the graph of this and then look at absorption and emission spectrum quickly. I wanted us to enjoy multiple choice a bit, but I still have outstanding questions. All right, we're going to the graph now. So what are we changing? We are changing frequency, right? Okay. Those of you at home, you can take a screenshot if you are still busy. I don't know if I can move on. Point to me. All right, guys, look at the graph of energy. When we talk about, it's the same graph that we know. Check this. It's that graph that we know, that we work with all the time. So I am changing frequency of light, and I'm looking at kinetic what? Energy. It is this graph that we all know. Do you remember this graph? Okay. What will this point be? X-intercept is known as the threshold frequency. The Y-intercept is known as your work function. Please, this is the last question in your paper on Friday. And the gradient is the Planck's constant. Gradient is the Planck's constant. And the examiner can play a bit of mathematics trick on us and ask us to work with 1 over wavelength. The graph remains absolutely the same because we know the relationship between frequency and wavelength. So we can just change the representation, but the graph remains absolutely the same. This one will still be our work function. This is 1 over threshold, and this is EK. Now, what is our gradient? HC. Because once I bring in wavelength, I bring in speed of light. All right, are we okay with the graph? This is the graph, and that's how to interpret the graph. Using y equals to mx plus what? C. Y equals to mx. Let me quickly show you how I got this y equals to mx plus c stuff. What is our equation? E equals to work function. But what is on my y? Kinetic energy. What is on my x? Frequency. So we just rearrange. Move this there. What do you have? EK equals to E minus work function. But I do not have E. I have HF. So that's why we see it as y equals to mx So that is my y-axis. That is my x-axis. Can you see why I equated my m and my h? And c generally is known as y what? Intercept, and it's a negative below 0. So that's a negative value there. So take note, if they give you this on a graph, we just do that. Every straight line in physics, you can solve with y equals to mx plus c. All right, we good? Can I quickly look at emission and absorption? I want to say absorption and emission together in one word. Emission spectrum. Oh, English never loved me. Let's look at emission spectrum. Okay, absorption and emission very quickly in one page. Now, the word absorb, what does it mean? To take in. I'm quickly going to explain this to you. Absorption. Please check this. We're going to have light passing through a cold medium. Once you see cold medium, know that the examiner is relating this to what? Absorption. And what are you going to have here at the end? So you have light passing through. What are you going to have at the end coming out? Absorption spectrum. Let's explain this very quickly. Let's use steps to explain this. Absorption spectrum. All right. Number one, light passes through a cold medium. And the light that is passing through is called a continuous spectrum. Passes through. I want you to take step-by-step approach to this. A cold medium. Now, what's the next step that happens? The electrons in the cold medium absorbs, that's the word, certain photons. Or let's say absorb photons of certain frequency. Let's use that. Absorbs photons of certain frequency. All right. Now what's going to happen after that? So when you absorb, all right, you absorb the electron. When you absorb a photon, what is a photon? A photon is a packet of what? Energy. It's like marrying a rich guy and you're still poor. That doesn't happen. Okay, maybe. If you marry a rich guy, what do? You absorb his wealth. If you marry a poor guy, you also absorb his wealth. Alright. So when you absorb a photon, you're absorbing it's like you're marrying somebody who likes fighting and you want peace. No, you absorb the anger of the person, you absorb everything. Alright. You can't say leave your anger by the door. I come with my anger. Alright. So the electrons in the cold medium absorb photons of certain frequency. And what happens? The electrons gain energy from the photons. And move up to excited state. What does excited state mean? A state of higher energy. they move up. They move up. Okay. Staying for no, it's Meleng. It's just it's unfortunate that that's the explanation that comes to my head at this moment, and I got to drive it in. Okay, let's check this. Let's check this now. So, different electrons are already at different energy levels, right? Before they absorb, they already at different energy levels. So, we're going to call this E0. Let's call this E1. Let's call this E2. So based on where they are going to increase in energy. Maybe from E, it depends. This particular one can even gain up to that, depending, right? There's no rule, depending on the type of guy you marry, your wealth.
Can't go from 0 to 4 to 3.
You can marry Elon Musk's son.
Elon Musk's son is a woman now.
He's a woman?
Yeah.
Okay, sorry. I didn't know that the son is not a woman. I'm not up to date. Okay. All right. I didn't know. God help him. Or her. Okay. I don't know. Okay, but check it. Is it making sense? So based on the amount of where you were before and the amount of energy you get. So these electrons move up into an excited means a higher energy what? Level. E0 is always called the ground state. And we can calculate the amount of energy obtained. Energy can be calculated, for example, if I say A, B, C, D. Let's calculate the energy of C. It's going to be what? E2 minus E1. Just we want that energy band. How much energy was absorbed? Make sense? Okay. And don't forget, while still on this, energy is directly proportional to frequency and inversely proportional to what? Wavelength. Which one has the smallest energy here? C has what? The smallest energy, lowest what? Frequency, but the longest wavelength. Are we okay, everybody? The last point on this now, number 4. The spectrum observed is a colorful background. Oh, my body is really lagging. Colorful background with black lines. The black line show the place of the missing photon. Because black is not a color. Black is the absence of color. So the photon that was responsible for that color has been taken out. Yes, Sbu, talk to me quickly.
So can you please explain how is the energy directly proportional to your frequency? I think about like the whole circle.
E equals to HF. H is a constant. So if the frequency increases, the energy of the light will increase. If just mathematically there, right? Because H is a constant.
Okay, thank you, sir.
Awesome. I'll give you a very good example. The frequency of red is what? Lesser than the frequency of yellow if you look at your Roige beef. Red, orange, yellow, green, blue, indigo, and violet. Red has the longest wavelength. Hence we say red shift, moving away. All right? Now, the color of the sun in the evening is red. The color of the sun in the afternoon is yellow. Where is it more hot? In the afternoon. Why? The frequency of yellow is greater than the frequency of red. Hence, the energy during the day is more than the energy at night, because yellow has a higher frequency than red. That's why you see all of this. Okay, makes sense. Those guys that wear, you know, this I don't know what they call it, reflectors. Yes, you can never. I don't go and check. You will never find a red reflector.
No, you find the yellow one.
Good. Do you know why? And that's a good exam question. Yellow shows more light because of the higher frequency than red. So if you go and buy a reflector and it's red, may God help you, because no one will see you. Okay. No one would see you. All right. So that's why we use yellow. In fact, we even use green. If you check, roid leaf. So yellow, green, because they radiate more energy because of the higher what? Frequency than red. I hope my explanation makes sense. So the spectrum observed is a colorful background with black lines. Where are those black lines? Why do we have black lines? The photon which was responsible for that color has been what? Absorbed. That photon right now is no longer there because the energy has been what? Removed. Hence we call it an absorption what? Spectrum. Please Google absorption spectrum and look at the picture. It's a colorful background, and you have, my board is lagging, so I don't want to, it's going to delay. You see a colorful background, but simple black lines. So maybe if you find a black line on a yellow part, it means the color which is responsible for that is no longer there. It has been absorbed in the cold what? Medium. What is now happening to the cold medium? The temperature has increased. The cold medium is now hot. Why? It has absorbed what? Energy. Move to excited. Cold medium is now hot. Cold medium increases in energy or temperature. Why? It has absorbed. Now let's go look at emission spectrum. Guys, did absorption make sense to you? Let me know. This is full details, and I'm going to explain something that was tested in one of the prelims. I think it's Limpopo that tested that. They gave a very, very beautiful question. I love it. I just remember that question now. And that question combined both absorption and emission spectrum. Okay, can I move? Emission spectrum. That would be a lot shorter than this. Quickly, emission spectrum. Now, a hot medium loses energy as electrons move from higher or excited states to lower or ground state. The energy lost is in terms of photon. The energy lost is a photon. The energy lost is a photon. So now we reverse our graph. Nothing stays hot forever. So the hot medium is now becoming cold. And what's the meaning? It means we are losing what? Energy. So again, depending on the amount of energy lost, same story like we did earlier on. E0, E1. So we can calculate E again, right? Because we are losing what? Energy. Oh my word.
What after ground?
Huh? Yeah. It needs me to restart. I don't know.
Sir, what after ground?
You said?
What's after ground?
Huh?
Ground.
State. The energy lost. Okay, Sitley, I abused my board. It's fine. The energy lost. Don't worry. You still have chemistry to do, eh? Is a photon.
Don't be spicy, sir. Don't be spicy.
I don't remember. Wait, a hot. Can you tell me the note? A hot medium does what?
A hot medium loses energy as electrons move from a high excited state to lower ground state.
As electrons move from a higher or excited state to a lower or ground state, the energy lost is a photon. Okay. What do we observe? We observe a black background and colorful lines. The colored lines shows the photon that is what? Emitted. The colorful line shows photon that is emitted. Shows an emitted photon. Hence, we talk about what? Emission spectrum. Now, application. The colorful line shows an emitted photon. Now, application quickly. Application. So I'm taking this from the Limpopo question. Yeah, Alan, I don't know. Somebody's stealing my letters. Somebody's stealing my letters. My letters have been emitted. It's an emitted writing now. All right. Okay, but managed to fix it. Application. When light of insufficient keyword energy, insufficient energy shines on a metal, what happens? Electrons are not ejected, right? That's the first thing we know. That's point one. Because of the word insufficient. You go to the shop, you don't have money, they put your ID there and say wanted. All right. Put your ID, wanted. But this doesn't mean that the electrons don't absorb what? The photons. Right? The electrons in the metal, this is very, very important, absorbs the energy of the photons and move to an excited state. What is this? This is absorption spectrum. So they do absorb, but the energy is not sufficient to knock off the electron. So they still absorb, right? Okay? Don't take a picture yet. Wait, let me finish. Now, don't worry. I have control now. I bought a new board. Don't worry. I'm that rich. Tumeleng says it's Sitley. Sitley is stealing my letters. I agree with you. Sitley is stealing my letters. All right. The electrons in the metal absorb. But remember, no electrons are ejected because of insufficient what? Energy. Now, what happens? The electrons lose this energy in terms of photons. And what is this? Remember, photons is what? Light. And this is known as what? Emission what? Spectrum. These photon released is responsible for the shiny property of metals. The photon released is responsible for the shiny property. So in grade 10 we say metals shine. This is why they shine. Because what we are seeing is the light from it, light that is emitted. The light emitted makes them shine. So this is an extended lesson now on absorption and emissions. Please let me know if it makes sense. When electrons are ejected, it is photoelectric effect. When photons are ejected, the metal will shine. And why are photons ejected? Because the energy of the electrons is not what? Sufficient. So you enter a shop, you don't have enough money. What do? You smile when you come out like, one day is one day. Like one day is one day. I'm coming back for you. That's what I did to my first Rolls Royce. I just walked in and walked out. One day is one day. Rolls Royce. Yeah. One day is one day. Until I just ordered. Take a lot. No. Take a lot. They deliver. If you have money, you can do anything. No, not this. The one that you drive. That was the one that has sound. Not toy cars. All right. But guys, I hope this makes sense. All right. And I'm glad we answered some calculation questions here. Just always make a list of what you have, and then we'll be done. Multiple choice. I know I did some. What? No, I haven't yet. Okay. What's the question? Is it it's a calculation, right?
Calculation.
Okay, guys. Let's look at before this child. I really don't feel like answering our question because it's from that Arsenal team. Okay.
Like when you get that wrong, everything else is gonna be wrong automatically. No.
All right. You said what paper is it? Can I quickly answer that question, guys?
It's November 2021.
November 2021. Okay, let's go look for it. Let's look for it quickly. Met is done now. All right, November 2021. So we'll end on this. No, guys, let's do more questions.
We're online, sir.
Prediction for Friday, Alan. Let me. I'll send some things on the group. Oh, can we answer this question? Look at number 10. Which one of the following combination correctly links an emission spectrum and an absorption spectrum to the energy transmission of an electron? Emission spectrum from low to high energy levels, absorption. So we see they are talking about what? Energy levels, right? Okay, so emission, we are losing. So what does it mean? From high to low. Emission from low to high. Which one is correct? Huh? You are so fast. You've read all of them. Yeah. D. From emission. D, right? You guys are fast. So maybe because I was talking. You scanned. Wait, nana. All right. So guys, you see that what we've done makes sense, right? And brought us some mark. Okay, let's quickly look at that. Oh, beautiful. Now I think I work for ESCOM. The way I love to do circuits. All right, let's take a screenshot of this and throw it in and quickly answer. We won't waste time on this, I promise. Okay, let's answer the first part. Just 2 marks. But these 2 marks, I promise you can lose it. The way I've actually quickly looked at the question. You got it right?
Yeah, I got question 1 right.
All right, let's see. The battery in the circuit shows an EMF of that and an unknown internal resistance, the resistance of the connecting wire, When switch S is open, always watch the switch. If it's the main switch, this is the main switch. All right. What is the reading on V1? When the main switch is open, we measure EMF. What's the EMF? 12. So my answer here is what? 12 volts. What about V2? There's no current in the circuit, so the voltage is 0. Are we okay? Now, another thing they can put for you. Let's do this. If I let's put a V3 there. When that switch is open, what are we measuring? We are still measuring EMF. So V3 will also be what? 12. But when it is closed, okay, I'll take your hand now. When closed, V3 would be 0 volts. Simply because a switch has no resistance. R is equal to 0. So what is V equals to IR? Whatever the current is multiplied by 0. Yes, Boo, talk to me.
So, but maybe when is the voltmeter 0? When is it reaching 0 volts? Because I get quite confused.
All right, do you see where V1 is? V1 is on the cell. V1 is on the cell. Can you see where V1 is? It's right connected to the cell. But V2 is in the circuit. So this one here would be 0. Why? There's no current flowing through. Check. If I say V equals to IR, but I is 0, it doesn't matter what's going on. But on the EMF, the one on the battery would measure the EMF.
Okay, thank you, sir.
You are most welcome. It measures the EMF. All right. Okay, so take note of the one on the switch as well. Let's quickly now go for serious questions. This one here, we're just warming up. Okay. Oh, 19 marks. All right, they said switch S is now closed. Let's walk through. Okay, so I'm going to be going forth and back in the question. I'm glad I don't have to do the first one. What is power? All right, the work done per unit what? Time. All right, switch S is now closed. The reading on the ammeter is 1,2. You know what I like to do? I'll go back to my circuit and start putting things there. The ammeter, it's now closed. Where's ammeter? Now that is closed. What happened here? 1,2A. Are you following? Beautiful. You're going to see that it's so hard to do. All right. Power dissipated by X is 5,76 watts. I think they wrote that there. Did they? Yeah, it's given. They wrote it there. We analyze first before we start answering. Let's go through. All right. Calculate the resistance of X. Beautiful. My dear learners, check what I'm going to do. When this thing is closed, current will move here from the positive to the negative, right? What is this current? Is it 1,2? All right. This, please watch. This current gets here and does what? It splits. All right. It continues. When it gets here, what happens? It combines. So it means the current here will be what? Now I'm done. Make a list of what you have. We have power, we have current, we're looking for resistance. What is the formula? All right, we are done there. P is equal to what? I squared R. What's your power? 5,76, 1,2 squared multiplied by R. Therefore, you want to give me an answer for R? 3 marks. Huh? 4. Done. 3 marks done. Make sense? Guys, when it comes to circuit, read your circuit through, write what you know on each of the resistors. Use your acronym, series are potential what? Dividers. Total external resistance of the circuit. Let's see. Total external. How many marks? 3 marks. Sweet. How many resistors? 4. But what do you notice? Guys, you need to know how to combine. You combine per line. Alright? Parallel there. But what do you notice? How many resistors are in this line? 2. How are these two connected? Series. Please get your calculator. I'm just going to be walking through with you. What do we do with series? We add. So that gives us what? 2,4 plus 6, 8,4. We're good. But that is in parallel to this. I don't know if you guys can see that. Let me help you quickly to see. If I combine those two, then I have one resistor here, I have another resistor here, and they are connected in parallel. What did we get here? 8,4. What is this? 6. How do you do resistors that are connected in parallel? 1 over. All right, and yeah, or you can use product over sum if there are 2 of them. So what is the product of this? 6 times 8,4 over 6. Give me an answer to this. Then I can add this to 4 ohms. I don't know if that makes sense. Final answer. All right, guys, I don't know if the process makes sense. First, the 2,4 and the 6 are in series. We got them together, 8,4. The 8,4 is in parallel with the 6, yes?
Sir?
Yes, Sibo.
What is actually meant when it said external resistance? I get quite confused. Is it when the parallel and the...
No, all the resistors that are outside the battery. All the resistors that are outside. There are 2 types of resistors. What is this one? Internal, because it's, can you see these dotted lines? It is inside. So all the other ones, all of these are external resistors that are outside the battery. Whatever is inside the cell is called internal resistance. Guys, are we okay with the calculation? Do you agree? What's the answer? All right, don't forget we had to add that 4. So you can get back home and look at this paper again. You said it's November what? Calculate the reading on V2. Let's look at V2. What is V2 measuring? Huh? All right. Is right on the 6 ohms. So how do I measure V, by the way? V will be equal to what? IR. So all I need to know is my current. Please watch this. Can I take this to a different page quickly? Because I don't want you to get confused. This is a very interesting question. Oh, and we are done with the calculations after that. Sweet maths or physics, whichever one. Please check this. Do I remember my diagram? I have that there. I have this there. 6 ohms, right? What is this? 2,4. Good. What current is coming here? 1,2. What was this other resistance?
6 was just 6 and a volt.
No. 6 ohms. All right, it's also 6. Okay, guys, let's quickly walk through this. So, yeah, my board needs real work. When current gets here, what happens? It splits. But don't forget, these two are connected in what? Series. So what happens? Same current. Series are potential what? Dividers. Current is the same. Let me help you. So you can do all of these little diagrams. When current gets here, it splits into 2. 6 ohms. And what is this? 8 comma what? 4 ohms. Are you with me? Current would split into 2. The question is, what is the current in the 8,4? Please understand that the voltage in the 6 and the voltage in the 8,4 are the same, but we don't know current. There are about 2 ways of doing this. I can work with ratios. Do you know how to use ratios? All right. Here, I have 6 and what? 8,4. Is that okay? Ohms. I want to divide 1,2. Check what I'm going to do. R is inversely proportional to what? Current. I'm going to switch my answers, because the one that has a higher resistance should have lower current. What is 6 plus 8.4? 14,4. So I'm going to say 6 over 14,4 times 1,2. I'm changing. This one's 8. This one, sorry. I said I'm changing, right? So this should be 8,4. Please give me an answer and you would see what we are just done. No, the 8,4 comes. I'm switching them. 6 over 14,4. Let's see the answer.
The first one is 0.7.
0, and the second one? 0,5. Guys, I don't know if you see what I've done. Do you see that the one that has the lower current, the lower resistance, would have the higher current? This is one way of doing it. So now I know that the current here, I'll show you another way. The current here is what? 0,5, and the current here is what? Do you see that 0,5 plus 0,7 would give you 1,2? Make sense? All right. What else could I have done to find current if I don't want to work with ratios? Let's see what we can do. Watch this. Let me see something here quickly. I need an information. This board is really lagging and it's annoying me. All right. There's something I wanted. What did we calculate earlier on? What was our first calculation? All right. We calculated total resistance, right? All right. I wanted to do something. I don't want to use ratios. I want to see another way of getting this. But I'm not done with that answer. But you can let me do that answer now. So I know that I'm looking for the V in the 6 ohms, right? So what would the V in the 6 ohm be? Current in the 6 ohms and R of the what? 6. What's the current in the 6 ohms? Because these guys are connected in what? Series. Does that make sense? So the same current would flow. So 0.7 times, what is my resistance? 6. What's your answer? 4.2 volts. You were marking, is that the same answer they got? 4.2 volts. But I want to do it in a different way where I am not using what? Ratios. All right. Where I am not using ratios. What should I do? You don't know. Let's combine the resistors. Guys, let's combine these two resistors quickly. Writing on this board tonight is just painful to my soul. What is this? 6 and what is this? 8.4. Let's find the total resistance. Everybody. What will it be? 6 times 8.4. Please press a calculator. You take a picture of this. Over 6 plus 8.4. All right, please watch this. We're getting 3.5, right? Ohms. So what is the entire voltage here? I multiplied by R. Since I've combined, it means my total current is going through there, multiplied by 3.5. Watch this answer. Answer. 1.2. That's the one they used. 4.2 volts. Guys, I don't know if what I'm doing, what I did made sense. Yes. Because in this block, guys, check. The voltage here and the voltage here would be the same. So we calculated the whole voltage there in that entire block by bringing all the resistance together and multiplied by what? The current. So I did it in 2 ways. Make sense? 2 different ways.
So ratios.
If you are doing ratios, you must switch them because resistance and current are inversely what? Proportional. All right, let's quickly finish. You can rewatch this tomorrow. Sit there, the way your eyes is. Okay, let me answer this because the rest is your story. Then I'll go back to that calculation. A length of wire of negligible resistance is connected to point P and Q in the circuit. I'll go back to that diagram, that calculation, and show you. So we connect a wire between P and Q. What is that? That's short circuiting, right? You know what that wire does? Takes out this resistance. All right. Takes out this resistance. Let's see. Already I know 2 resistances are out. Let's see what the question is saying. The question here, we're going to use revive. I'm so sure. All right, let's see. How will the reading on V1 be affected? Okay. I told you it's revive. Look at what we are doing, guys. Already, this is the main thing. I am removing a resistor here. This resistor is in series. So if I remove a resistor in series, let's get a quick page. All right, I want to answer it here. All right, so we remove a resistor in series. What happens? 1, R total decreases. If you remember revive, if R total decreases, what happens? I total will also what? I total will what? Increase, because they are inversely what? Proportional. That's Ri. What's the next letter? Vi. V internal. What will happen to V internal? It will increase. V internal will increase. Why is that? Ohm's law. If V internal increases, what happens to V external? V external will decrease. Look, how many marks? 4. Each step. 1, 2, 3, 4. Revive. And we adonai. Most of these ones are answered. The last questions are answered using revive. Are we good, guys? So each step, but please don't write Chinese there. Write decrease, increase, because that's Chinese. Jehon, lehon, chok, R total jehon, I total lehen. Yes? Anybody saying something there? That's Chinese. Yes.
When you write the E, we still use the signs, or do we write out the word?
Which one?
So for when we write the last question, increase or decrease, the arrow up or down when you write the full word.
Don't write arrows. That's what I'm just saying. Don't write arrows. Please write the full words. Increase, decreases. Don't use arrows. That's Chinese. R total decreases, I total increases, V internal increases, and V external what? Decreases. And if you swap it, just change the signs. All right, are we okay? Sitlin, here's what you want to look at. I'm done, but just wait, because somebody might say something that might be important. Yes? Yeah, what confused you? On the left. On top. Okay. Yeah.
And the voltage under 6 are different.
Yes.
But somehow the voltage on 8.4 is the same as the voltage.
Let me show you something quickly. Get a calculator. What is 2,4 times 0,7? I want to show you SAPD. 0,7 times 2,4. 1, all right, so the voltage here is 1,68 volts. Now, what is 0,7 times 6? 4,2. 4,2. Okay, wait, what's going on there? Wait, let me see something. What did I do? Because that's supposed to give me, if I add those two together. Okay, wait. What is 6? Hold on. Maybe I'm misinterpreting something. What did we do first? We decided to calculate the current, right? The current here is no, 0,5. Remember, 1,2 comes in here and is divided. We got 0,5 here and we got 0,7 here. So the 0,7 is the one that flows in here and in that point. All right. Okay. So here, oh, I see what's going on. Because the voltmeter is right measuring And because this and this, 8,4. What is 8,4 times 0,7? Just want to check something quickly. Eh? 5,88. What is 6 times 0,5? That would be 3. Okay, wait, something is not making sense here. I know even if they got 4,2, so, and we got 4,2 as well, I want to see what I did here that led me to that 4,2. I tried to calculate the total voltage in this whole block. Are you sure 1,2 times 3,5 will give us 4,2? There's something that is not making sense. But I do agree with this though. This I agree with. Because we calculated the current here, current there, right? And then, all right, 4,2. I'm just going to check and see something on that side. Total resistance, total, but it's still fine. Total resistance, total current, multiplied together will give us the total voltage in that section. 4,2 volts. Yeah. But something is not making sense. But so far so good, we're good. Maybe I'm thinking extra. All right, guys. If there's any question, let's talk. Aha! Sitle, you here? This child just joined in. Sitle Manzini. Hey. Yeah, you have a twin here. And both of you are just my headache. All right, guys. Sibu, what's the question?
So just a general question. When completing the multiple choice, do you think that we should always refer to the formulas if it's needed or what?
Absolutely. As long as it's physics, formulas are always required. Google.
Evening, sir.
Hi, Google.
Hi, sir.
How are
Sir,
you?
I'm confused with the 14. I'm getting something. I'm confused with the 14,4 and the 6,5.
The?
Because isn't it the 14,4
Yep.
and the 6,5?
No, here with the 14,4, I was looking for the current, the total current, right? Current in each of the things. So you have 1,2 coming in here. All right, my board is lagging. But the 1,2 goes into the 6 and the 8,4. Are you okay with that?
Yes, sir.
So we are dividing 1,2 between the 6 and the 8,4. So I was using ratios
Okay.
to say what amount of current would go into the 6. Remember, they are in parallel, so current is divided. What amount of current would go into the 6 and what amount of current would go into the 8,4?
So the 14,4 is the total resistance.
Yes. So just like you do ratios, if I say divide, remember grade 8, divide 300 in the ratio 1 to 2. What do? You add the ratios together, then you remember that stuff? No. Aha, I got you. Okay, check this. If I say divide 300 in the ratio 2 to 3, what do? You add these ratios together. So
Yes.
2 over 5 times.
1,500.
Yes, that's exactly what I did. So I added my ratios together. 6 plus 8,4 would give me 14,4. You see, the total goes to the bottom. Then the top, 8,4 times the current that I want to divide. So that gave me 0,7 and the other one gave me 0,5. But resistance and current are inversely what? Proportional. That's why I'm switching them. The one with the higher resistance will have the lower current.
Oh, okay. Okay, thank you, sir. I understand.
Oh, I think I see where I made a mistake here. Yeah, I see. Okay, now it makes sense. I see. Let me fix it while you are here so that anybody who watches it will. I see my error here. It's not making sense while I'm talking to you. this should change. The 6 ohms should have what? 0.7. While the 8.4 should have what? Yeah, that's why it was not making sense. 0.5. Let me fix it while you're here. Let me fix it while you're here. So we said that was the error there. I know it wasn't. I wasn't feeling so good seeing that error. Okay, so this is the 6 ohms and this is the 8.4. So we said the current here is 0.7. Okay, that was what that child was saying, and I just missed it. 0.5. But the 8 ohms, the 8.4 ohms, is made up of, yeah, it makes sense now, 2.4 ohms, and then we have what? 6 ohms. Because they are connected in series, my current is still what? 0.5. Yes, now it should give me what I want. What is 0.5 times 2.4? Do you want to give me an answer there quickly? That is 1.2. Yes. Now it is making sense. And this is what? 6 times 0.5 would be what? 3 volts. Yeah. Now, 4.2 volts. I wanted to get that 4.2. Did it make sense? I made a mistake. I switched those things there. But did it make sense now? All right. So I made a mistake on that particular page. My board is also not helping matters. All right, so this is 0.7 amps and this is 0.5 amps. Okay. Yes. Okay, this answer will still be correct because these guys are connected in parallel. Yeah, so we're okay. That's good there. All right, guys. I hope everybody is good. I'm glad I could see that error and I corrected it. Okay, that doesn't want to go. All right, guys, if there's no more question, we are done. Can we watch this? I'm going to upload immediately. All right, goodbye. Hi, Sidley.